Sine is 1 over cosecant. We've defined it this way, and we've said, well, cosecant. Well, we define this one. So obviously, if you were to flip both sides, you would get the other one, right? We've said tangent is equal to sine over cosine, and cotangent is the opposite, actually a reciprocal, which leads you to these two. So all these, I'm not going to force you to memorize it like my teacher did, but have them with you on a formula page when we get to, whenever you're doing your homework or the next exam, you're going to need to do it. You're going to need to use it. Well, all of these, pretty much 99% of all these formulas come from here. So you do all kinds of fancy algebra and identity stuff, and you'll find this one, etc. They'll all come about. Okay. Which is pretty cool, but I don't want to spend an hour showing you. Let's just have them at the ready and try them out. Okay, so make sure you have that open. That's that PDF file I sent you. Can you see the homework?
Yes.
Okay. Excuse me. So the original, obviously, as we just said, is equal to 1. The sine squared plus cosine squared is equal to 1. Sine is an odd function. So the definition of odd, do you remember? You plug in any negative number, it's the same as plugging in a positive but multiplying by a negative. Is that familiar? Even is if you plug it in, it's as if you plugged in a negative. Okay. I'm gonna put the caption on that way I know who's participating. I'm gonna try to award extra credit for participating. That way I'm not just talking to a wall, falling asleep over here. If you want to. But anyway. Even and odd. Sine is, most of them are odd except cosine and 1 over secant. So this would be equal to negative sine u. It's just the identities from the sheet that I gave. Okay. These are definitions from college algebra. Is there any questions on 1 and 2? About the definitions?
Do we have to put the negative sign the u in parentheses or no?
You don't have to, but I don't trust the program, so I would probably just put them just in case.
Okay.
This is the another identity. Where did I put those things? Here? No, it's 5. Right, found it. Here it is. It's here on the right, correct? It was the secant one, right? Right here. Secant 2 pi plus secant is secant. Do you see why though? Why this is secant? We have pi over 2. Okay, my bad. Those are somewhere. Oh, the reason it's secant is because of the period, right? If I add 2 pi, I end up at the same spot. It's based on the period. For secant, cosecant, sine, cosine, every 2 pi, it goes back to where it started. It's a cyclical function, if you remember the graphs. So it makes sense that this wouldn't change. If I add 2 pi to the angle. Do I have one with pi over 2 though? I believe I do. Here they are. They're called the cofunction identities. So secant, if I were to shift it by pi over 2, it becomes the other function. So this is the identity. So they're not really making us solve anything. We're just applying it. We're making sure that we know the identities and understand that this is a horizontal shift. So this moves it and it ends up turning into this. So kind of like when you move sine a little bit, it turns into cosine, because sine and cosine look the same if you remember the graphs. Do you remember the graphs for sine and cosine? Do you see? Oh, go ahead. Visually, do you guys see that these are the same, or why they are? Those two?
Like graph terms would be like,
Yeah, with the graphs.
like it's reflected.
They're the reflection of each other, right?
Yeah, they're very similar, but not necessarily reflections.
Are they what's the word?
So
The
is it
inversions of each other?
shifted?
Like complementary. I forgot the word.
Reciprocal? No, not reciprocal.
It's like it starts with an I, right? Like the invert.
Let's graph it and see. I think
Isn't it shifted? Isn't like the sign shifted?
yeah, that's what it is. It's the shift. Oh, here's my imaging. Yeah, exactly, the shift. So we know back in college algebra, right, if you had something inside, it would cause into parentheses the argument. It would cause it to shift. But notice that they are the same graph, they just start in different places, right?
Yes.
Cosine is blue. Sine is red. Oh, I'm sorry. Cosine is red, sine is blue. So this shift is this pi over 2. So do you agree that if I shift the red one on top of the blue, that they would be the same?
Yes.
So that's where this comes from. These, all of them. If I shift them to the right spot, I can make it turn into one of the others. But they weren't asking for all that. I just want to make sure you understand those concepts. So this guy, you just look at your chart and write down the answer. Just make sure you understand like why is that? Okay. Okay. Number 4. This comes from the original identity. Okay. Now, if I were to divide, so this is an equation, so I can divide and multiply it by anything that's not zero. So in order to make it into this, right, if I divide everything by sine, I divide the original. This would be 1 plus cotangent equal to cosecant. Do you agree? You all see that it becomes that next line.
Yes.
Okay, so if I were to solve for, if I make it look like this one here. Do some algebra, we got my x. Do you agree that it's equal to -1? Yes, I should follow that. I'm not gonna force you to derive them. But deriving them kind of helps you get a grasp on where they come from and how they work. If we go back to the formulas though, it looks like horrific. The Pythagorean identities. See, they're right here, but they didn't give you every permutation. They just gave you one set of each type. This is the one where you divide by cosine on every term. This is the one where you divide by sine on every term. And this is the original. But you see that if I move things around, I can create 3 more formulas, or each one will create 2 more. So there's technically a total of 9 by doing a basic algebra. You see what I mean? Or is that weird?
Yeah, it makes sense.
Okay, so they're using these. That's all we're talking about. That's it. That's where this comes from. All right, number 5, there's actual work to do. So here we're going to use our identities to simplify the problem. So on the actual exam for chapter 7 is one of the harder tests because it's very different. We're not really solving for anything. We're just trying to prove one side is equal to the other side. That's it. And on number 5, we're not even doing that. We're just simplifying it using identities. So keep using those identities to help you out. So we have cosine times this garbage. Multiply, you get cosine. Right, just distribute. What is tangent equal to? Look at the identity page, because you have to be able to see that on your own.
Is it sine theta over cosine theta?
Yeah. So right here. I have sine squared x over cosine squared x. So do you see that this will cancel one of them?
Yes.
So now we have an ugly two. Okay, so now add the fractions. You see that this is the LCD is cosine. This is just a one, right? Okay, so multiply both top and bottom by cosine. Multiply by cosine. Okay, so now they have the same denominator. So add them together and we have cosine squared plus sine squared over cosine. But what is cosine squared plus sine squared?
Is it one?
One, yeah, one.
Yeah, it's gonna be one. Now look at the sheet. What is one over cosine?
Secant theta.
Yeah. So the answer is right here. But the work I want to see is something like this. So show every step, do your algebra. Yeah, maybe you can skip a small step here or there. But this is the idea. Does it make sense? Some are harder than others. Some not so much. Any questions on 5? Okay. I'll move on to 6 then. The same type of deal, cancel stuff out, see what happens. Make sure you're comfortable with fractions because a lot of the simplification will happen once you add fractions. So cotangent is is equal to this, right? What is secant equal to?
One over cosine.
Yeah, so use your formula sheets to help you. So right away, you should see that those are gonna cancel. So now we have 1 over sine. What is 1 over sine?
Cosecant.
Yeah, cosecant.
Secant.
And we'll be able to use this sheet during the test to assist, right?
Yeah, of course.
Okay, awesome.
Yeah, I'm not gonna make you memorize it. This, I feel like it's not what math's about. Math's about process and practice. Not memorization. It's not history. You guys cool on 6? Making sense though? Like, I know. It's all gonna come down to algebra like always, right? But algebra paired with that formula sheet, you should be good, just some of it might be annoying.
It is.
Yeah, it is. I like to think of it as a weird game.
Definitely need to print it out because it's hard going back from Zoom to the thing fast enough.
Yeah, print it out, because you're gonna use it for the test anyway. Okay, so again, it's easy when I'm doing it, right? So let's pretend you're doing this. What identity should I use on the top? Look at the sheet.
Oh, sorry.
Oh, you're good. Look at the sheet. What do you think? Or maybe you said the answer.
No, I couldn't see. I didn't have my glasses on. I was trying to look for them.
We
That's
could tan squared theta plus 1.
Yeah, you mean this one right here?
Yes.
Yeah, if we subtract the cosine over, we get minus sine, right? So 1 minus sine squared. Oh shit, I'm sorry. Damn it. That's cosine. Subtract the cosine. You know what? I think I'm mixing myself up. What the heck was the question again? Secant. My bad. I think you said the other one, didn't you?
Yeah, the tan squared.
The 10.
Secant squared minus 1. Yeah, it is tangent. My bad. Okay. So tangent. So there we go. Let's do it. Again, there's no wrong way to do this. Just try using an identity and see if it simplifies. With experience and practice, you'll start to see which one you should change. So if I use the identity, I get a tangent squared, right? So now we're here. So you should think, okay, well, what can I do now? What would you do?
Multiply.
Yeah, let's deal with this fraction. What is tangent?
Sine over cosine. Are we looking for like the tangent identities or?
Yeah, that's the thing. Like, what do you want to try? You have to decide on your own. Do you see something that stands out for you? And if not, just try something, see what happens. So right now I'm seeing, I know there's a sign inside of here, inside of the tangent. So I'm thinking maybe change it to that ratio and then divide it. See what I mean? So now we have a simplified version. What is 1 over cosine?
Sine.
Sine, let me see.
One
Oh,
over
1 over cosine.
Oh, cosine, sorry. Secant.
So yeah, there it is. So whenever you just try to see patterns. For example, whenever I see a square minus 1 or minus another square, I think, oh, maybe the Pythagorean identities. And then I saw that it's tangent. I'm like, okay, well, maybe that tan can cancel something with the sine. And if it doesn't work out, just start over and try something else. Okay, like I could have changed the sine squared into something different. I could have multiplied the top and bottom by something that could make it easier or maybe make it worse. Right? So just try different things. If it starts getting ridiculous, then you probably chose the wrong path. It's like, all right, you guys cool on 7?
Yeah, I see there's multiple ways to do these. Some are longer than the others. Yeah, I see now. Because we could have
For
used
sure.
the sine into 1 over cosecant in the beginning. And
Is that what you tried?
I was just looking through, just like skimming and how the other way we can do it. But
Yeah,
think
I think
the way that you did it's easier. The one that I was gonna do is much more
Yeah, you're gonna see that in the homework, you're like, oh, maybe I should try something different. But yeah, make sure you write them all out in practice, because the answer, like I said, like the answer's not important, it's just how do you get there? Same thing over and over. What would you try on number 8? Anything jump at you? Well, nothing jumps at you. Let's look at the formula sheet. I don't know.
So would it equal to sine over cosine? And
Yeah.
then equal tangent? X.
Sine squared over. Oh, let's see. You're saying change the top, right?
Yes,
So the top becomes sine based on the identity. The only thing is it's a square. So it's not, well, it's almost tangent, so we kind of have to force it. So this is where we're doing strange, thinking outside the box, I guess. Do you agree that sine squared is sine times sine?
Yes, would it be a double angle identity?
No, I mean, you could use it, but I don't think it would be helpful, but let me see,
The cosine,
check, maybe you're right. Double angle. It's right here. No, because we'd have to have,
it had to be,
yeah, it had to be by itself, right? This has a bunch of stuff. We could maybe use these Pythagorean, maybe. But let's still go back. I think right here, because you guys were saying tangent earlier, isn't this tangent right there?
yes.
yes.
So
Sine times tangent, right?
yeah,
Oh, that one was really simple.
yeah, it's really simple, but to see it is kind of weird, right? Like,
Yeah, you have to write it out so you can really see it.
yeah. If you separate the fraction like this, then it's super obvious that this is sine tangent. Do you see? For everyone?
Yes.
Yeah, that one's not obvious because you're like on the, when most of the time when I see this, I'm thinking, well, I should try the Pythagorean. Sine squared is equal to 1 minus cosine squared. That'd be my first attempt. Right? Then I could maybe separate the fraction and hope something useful comes out. I'm just curious. Now I got 1 over cosine minus 1. Which is secant minus 1. That doesn't help at all. So what you could do. Yeah, that doesn't help. Because if you think about it, right? I mean, I know this is the answer. But now I'm subtracting and I don't have a product. So I don't think that's the right path. I was wondering if it would work out, but. No. But that would have been my first instinct because I see a square. And that's what you should think about, but it turned out to be the wrong path. Anyway. You guys cool on 8, right?
Yes, sir.
Yes.
Annotate. They're all pretty much similar. They're just using different techniques. Here we're doing factoring and seeing if we get an identity. Same thing for 10. 10, 11 is factoring. This is more of a quadratic type factoring. This would be a difference of squares and see if anything pops up. Yeah, let's do. I'll do 10 and then I'll skip to 11. So do you see that they both have tangent in common, right? So factor out tangent when 1 minus sine squared, what is that equal to on your identities?
It is 1 over cosecant.
1 minus sine. One minus sine, you would have to solve for it here. So if I move this sine over here by subtraction, you would get this, right? Oops. So 1 minus sine is actually cosine squared. That makes sense? So use that guy.
Yes, you just have to play around with it.
Yeah, I mean, if you want to write down every possibility, then you can create 9 more or 6 more from these first 3. It's up to you. I don't think it's necessary, but maybe you want to. That's cosine. And we should see that this reduces, right? Change, how do we change tangent to cancel the terms?
Would you change it to sine over cosine and then?
Yeah. So this most simplified version is this. Is that clear? So do something similar for 11. Twelve and 13 are factoring, so let me do, I don't know. 13, I guess. So we should see that this is equal to cosecant squared right? Minus cotangent squared. So this will become the difference of squares, right? Using the formula. Is everyone with me on the difference of squares? I set it up that way to use the difference of squares formula. Instead of, so this becomes this, right? You guys cool up to that point?
Mm-hmm.
Okay,
The differences of squares, yes.
right, what do we do next? What y'all think?
You have to introduce the plus or minus.
Yeah, we do it again, right? With this one?
Yes.
So. Although. Would that wouldn't be simpler, that would be more complicated, wouldn't it? They said simplify. Let's look at our identities.
Yeah, we could use we could change the cosecant squared into cotangent squared theta plus 1 with the Pythagorean identity. Because then
Yeah, I think, yeah, those would be the routes. Uh, yeah, so Pythagorean identities. If we move over the cosecant, but if I subtract over the cotangent, this whole thing is a 1, isn't it? This becomes a 1. Cosecant squared plus cotangent is not an identity. I feel like this is more simplified. Do y'all see any further simplification? I currently don't. Okay, then, I guess that's it. On 12, you're gonna factor like trial and error, like trinomial factoring. I'll leave that for you. Yes, cool on 13. Number 14, use the even and odd properties for tangent, and then it'll reduce because the cosines will cancel. So you'll end up with a negative sine x for that guy times 6 negative 6 sine. On 16, try the Pythagorean identities on top and bottom, see what happens. Something should cancel if you choose the right one. Make them into something that might cancel. $17. What would you do? What would you try?
Cotangent?
Oh, we can't use cotan for 17. Oh. This one minus sign, right? They're separate. But if you see a cosine squared, you should be thinking, oh, maybe I should try the Pythagorean. I don't know if that's the best way. But for sure you have squared formulas, right? What is cosine squared equal to?
1 minus
Cotangent plus 1. Cotangent or cosine, sorry.
Yeah,
Sine over sine minus 1. Wait, is it
so we're gonna use this one.
the top one? Yeah.
So solve for cosine, what do you get?
It's
1 minus sine
1
squared.
minus sine squared.
Yeah. Solve for it, you get this. This kind of looks like the bottom, doesn't it?
Yeah, so will then it just cancel out and be 1.
That's very tempting. I was thinking the same thing, but that's not true. I want to do that, but no.
It's too simple.
Yeah, it's not the same because it's the square is only on the side on the
Top.
side.
Yeah.
It would have to, the whole thing would have to be square to cancel.
Mm,
See what I mean?
yes.
They look the same, but they're not.
They're
So
not.
factor the top is what you want to do. Does anyone see what type of factorization that is? We just did it earlier. Hint.
Differences of squares.
Yeah. So 1 plus sine times 1 minus sine. Now we have one that's exactly the same. So the I. So this is more simplified, right?
Yes.
Any questions on what we chose? You see how you kind of have to like getting started is like the hardest part. Like, all right, what do I try? What do I do? Like the algebra maybe is whatever, but deciding what to try is difficult. So
So
if you don't,
best practice, if we see a squared, it's most likely the Pythagorean or the Pythagorean identity.
yeah, exactly. If you see a square, think about it, Pythagorean. If you see like tangents and secant, like, all right, maybe I should add them together and see what happens using the LCD, or maybe change them into something that will cancel the other, stuff like that. This is another difference of squares. 18. We're not gonna do, yeah, so this is literally different of squares. You guys cool on 17? Alrighty. Nineteen, just add the fractions and see what happens. Or I guess subtract, but you know what I mean. 20, same deal. 19, 20, just add them up. Okay, let's stop here. You guys have any questions about today or any issues you're having or any homework problems? Pause record.